The HIRIS journey kicked off on the 1st of March 2018, following the signature of the contract between Safran Data Systems and the European Commission under the Clean Sky 2 program. For this purpose, Safran Data Systems is among 40 partners selected and coordinated by Airbus Helicopters for the manufacturing of the Racer helicopter prototype. HIRIS is the name given to the innovative flight test instrumentation for the Racer's 3 rotors, and its primary characteristic is to be 100% wireless, which will ease the implementation and the maintenance of the flight test instrumentation system, and at the same time will increase and improve technical performances. One of the HIRIS installation's keys for success on the Racer was the ability to demonstrate this new technology on an existing helicopter. This has been possible thanks to the helicopter behind me, the H-175. Nowadays, when it comes to helicopter rotors, how can we obtain a result just as reliable as with wired technology by using wireless technology? There are numerous challenges. First of all, around 30 megabits per second need to be transferred without any loss of data in the wireless transmission, despite the rotor masking associated with rotation. For this reason, the HIRIS system is comprised of 2 major subsystems. One subsystem for the power supply of the flight test instrumentation system. A module converts the 28 volts present on the aircraft into a magnetic field. This magnetic field is transmitted from a fixed coil to a rotating one. This supply must be fed by wireless technology without using batteries, and includes a remote monitoring system of the device. The second subsystem allows communication between the data acquisition unit installed on the rotor head and the flight test instrumentation network, which is located inside the cabin. There is one antenna positioned at the top of the rotor head's cup, and one positioned on the top fin tail boom. This wireless link allows data to be transmitted from the sensors. A large variety of data must be transferred from traditional sensors such as strain gauges, temperature, vibration, and also new digital sensors and optical fiber technologies. Then synchronization. All data from the 3 rotors, including that acquired on the helicopter's fuselage, must all be synchronized with a precision of 100 nanoseconds. Of course, the systems installed on the rotors must be configured by wireless connection and by just being connected to the flight test installation's Ethernet bus. In addition to these technical challenges, there are environmental and installation constraints. The system must meet the standard DO-160, with particular attention regarding the helicopter's vibrations. Then, installation and mechanical strength constraints. The system must meet regulation CS29, applied to the helicopter's rotor, to ensure flight safety. Finally, such a system must be usable on any type of helicopter or aircraft. The HIRIS, developed by Safran Data Systems, offers an operational technical solution to all these challenges and constraints. Data is sent to a gateway receiver located at the rear of the aircraft. This gateway receiver transforms the data into Ethernet packets sent to a recorder. The recorder records the data and transmits via a DTR-DM transmitter to the remote telemetry room on the ground. Reception on the ground is done by a ComTrack antenna connected to a RX1 receiver that delivers the message in Chapter 7 to the GMDR6 recorder equipped with an MTV-ME reception card. The GMDR extracts the Chapter 7 message and transfers the data to the operational visualization room in accordance with the Chapter 10 Ethernet standard. Our telemetry ground means include 2 sites. Before the Racer's takeoff, we are planning the creation of a 3rd ground station. The 3 ground stations will be connected via an Ethernet network, according to the IRIG 218 standard, to a best source selector, which will choose the best signal. The 3 caption sites will be finally controlled by the Maestro software suite. This initial flight data, as well as an initial post-flight data analysis, are very promising. We have actually opened up the entire flight envelope of the H175 from stationary flight up to speeds reaching 170 knots, and initial results are that the HIRIS system is not affected by flight conditions. Related to rotor rotation for speeds lower than 400 revolutions per minute and the masking effects due to the rotation of the blades. Here too, the HIRIS system is not affected by this phenomenon. We found that very few data are lost during the transmission. Of course, the initial results are only the start of a development plan during which we will be trying to explore the system's limits, such as, for example, increasing the flow of data transmitted between the main rotor and the fuselage, or even the rotation speed for exceeding speeds of 2,000 rotations per minute. These development and readiness plan trials are indispensable for removing any potential doubts about the results provided by the HIRIS system in order to guarantee the Racer's initial flights.